Alright, grades, welcome back. We are going to quickly look at what happens when law 1 and 2 gets combined. As I've mentioned before, we are moving towards law 3 and law 4, but first we need to just make a pit stop at looking at what happens when we combine law 1 and 2. So there are two things I need to keep in mind here. As always, we need to keep BODMAS in mind, and the other side, when multiplying two terms, we need to keep SNV in mind, so signs, numbers, then variables. Okay, so firstly, keeping BODMAS in mind, we've got a term here being multiplied by another term in the numerator, and then we've got a singular term in the denominator. So, as always, if there is any operation in the numerator, like this multiplication, we are going to treat it as if it is in brackets, meaning that we need to do that first before we can do the division. So that means I'm only going to look at my numerator for now. So my denominator remains unchanged. So for now, I'm just going to rewrite my denominator as it is and draw my division line. Okay. Now we can see at the top that we are multiplying two terms, and that is where SNV is going to come in. So let's first look at the signs. There's a positive 3 times a negative 2. Positive times a negative is going to result in a negative. Okay, so that checks off the signs. Then we go on to the numbers. Again, it's only going to be applicable to numbers that aren't being used as a base. So these numbers do have a power of 1, but we do not consider them a base just yet. If they have higher powers, then we'll consider them to be a base. For now, they are just numbers, so we can say 3 times 2, and that's going to give me 6. But now I need to look at the same basis. Remember, the first law speaks about multiplying the same basis. So I'm going to stick to those colors. And let's look at the a's. We've got an a squared times an a to the power 1. Multiplying the same basis, we are going to add the exponents. So 2 plus 1 is going to give me 3. And then when we move on to b, b to the power 1 times b to the power 3. Again, same basis. Add the exponents. 1 plus 3 is 4, so b to the power 4. Now at this point, we've got a singular term being divided by a singular term. Let me get them where they belong. Neaten it up a bit, and actually let me get the colors the same as well. Just so that not going to be easy apparently, just so that it looks the same. Let's get B there as well, so we know which ones we are working with. So now we can apply our second law and we can divide, again using SNV. So signs first, a negative divided by a negative will always result in a positive, but we do not write it, so we're going to leave that as it is. 6 divided by 12, now we can't do that, but we can say that 6 can divide into itself once and into 12 twice. So we can simplify this fraction down to a half. And I am going to write the 1 there for now. If that is the only thing left in my numerator, then it has to be there. If there's any variables or things left, then the 1 doesn't have to be there. Okay, moving on. We've got a to the power 3 divided by a to the power 3. Now, later on, we are going to say that it simply cancels out. Now, I did, in the previous lesson, quickly explain to you what happens here, but let's just make a block around this. and have a closer look to what is actually happening. Why can we say they cancel out? If we isolate this and we say, well, this is a to the power 3 divided by a to the power 3. This should remind you of what we looked at earlier or in a previous lesson. If I divide something by itself, we always say it equals to 1. Okay, but we need to look at why. Why does this equal to 1? If we apply our exponential laws, we know that we are dividing the same bases, so we need to subtract the exponents. 3 minus 3 is going to give me a to the power 0, and anything to the power 0 is always equal to 1. And since all of this is being multiplied, remember I can rewrite this as a negative 6 times a cubed times b to the power 4 over, well, this would be over negative 12 times a to the power 3 times b to the power 2. So they are all being multiplied, but we are only going to care about the ones that share the same base or whether they are just numbers. So in this case, this whole part here just becomes 1. And 1 times anything is going to stay the original number. So if I've got the negative 6 times 1, it's going to stay negative 6. 1 it being our multiplicative identity means it does not change the original number. Okay, so for now, we're going to say that simply cancels out. Then we look at our b's. B to the power 4 divided by b to the power 2. Again, we're going to use the shortcut. I'm going to subtract the smaller power from the larger. So 4 minus 2 is going to give me b to the power 2. My larger power was in the numerator, so my answer goes in the numerator, b to the power 2. And now that I know there's something in my numerator, not nothing, I can exclude the 1. I do not have to, but I can, and I can say my final answer is b squared over 2. Okay, let's have a look at this second example quickly. Let me grab it. There's only 2 of them. It's going to go very quick. Let's have a look here. Now in this case, we've got a multiplication in both numerator and denominator. So again, BODMAS is going to tell me I need to sort out the numerators and denominators separately before I try and use my second law. So we're first just going to use the first law in the numerator and in the denominator. So, in the numerator, we've got a positive times a positive, so that stays positive. We've got 6 times 2, which becomes 12. X to the power 2 times x to the power 1. Same basis, so add the exponents. 2 plus 1 is 3, so x to the power 3. Y to the power 3 times y to the power 4. 3 plus 4 is going to give me 7. So that's what I end up with at the top in the numerator. In the denominator, again, signs. Positive times a positive stays positive. 3 times 4 is 12. X times no x in the second term is just going to stay x. You can write to the power 1 if you would like. And no y times y to the power 7 is going to stay y to the power 7. Now look at what we've got. We've got 12x to the power 3, y to the power 7 divided by 12x, y to the power 7. Again, if you think about splitting this apart into the 3 separate parts it actually is, I'm going to do it over here. Let's stretch it out a bit, and let's split it up. I'm going to make some space for myself, just so you can see what is actually going to happen here. Right, almost there. These can be treated as 3 separate multiplications. 12 divided by 12 is going to be 1. Something divided by itself is 1. They cancel out, leaving 1 behind. Let's ignore the x in the middle for a second. Let's go to the y's. Same thing. Y to the 7 divided by y to the 7 cancels out, leaving a 1 behind. Here, however, they do not fully cancel. Here we need to use our exponential law, the second one. This is x to the power 1. So this bigger power minus the smaller power, 3 minus 1 gives me 2. My larger power was in the numerator, so I'm left with x to the power 2. You can say this cancels here, leaving us with x to the power 2 at the top. So what do we actually have? 1 times x to the power 2 times 1. Multiplying by 1 is not going to change anything. So in actual fact, we are just left with x to the power 2. Have a look at the left-hand side here. If we simplify 12 over 12, that would be 1. X cubed divided by x to the power 1 leaves me with x squared. Y to the 7 divided by y to the 7 leaves me with a multiplication of 1. And again, this 1 here doesn't have to be here. Timesing by 1 is not going to change anything, so we are left with just x squared. So, last thing I do want to mention with regards to this and all algebra grade 8s. You can always test your answers. Okay? When you've got any algebraic expression like this, again, we will visit your expressions and equations chapter later. I will just quickly tell you an expression does not have an equal sign in it. That's why we can put equal signs at the start. Whereas an equation, if I say something like this, has an equal sign in the sum. That's why if we go to the next step, we're going to use our therefore sign. That we do not have multiple equals in the same line. Okay, when you have any expression, however, you can test it simply by picking a value for x and picking a value for y and see if your answers match up. I will, however, say you can pick any value, do not pick something too large, since you are raising it to quite big powers. And do not pick 0 or 1, because from our definitions, 0 and 1 is problematic. So pick anything from 2 upwards. I would stick between 2 and 10, and avoiding decimals as well, because it's just going to make things messy. I'll show you here with the second one what I mean. So let's get rid of this. So if I was doing this in a test and I want to see that this answer is correct, I would pick x to be 2 and y to be 5, for example. It could be anything, like I said, avoid 0 and negatives, but other than that, it can be anything. Then I'm going to go and type this in on my calculator, changing the x's and y's with 2's and 5's as they need to be, and using brackets. So let's see how I'm going to type that. So I'm going to make a fraction. I'm going to say 6 times x. X we know is 2 in a bracket because it still has to be squared. And that has to still be multiplied by y, which is 5 in a bracket, which still has to be cubed. Then that has to be multiplied by 2. X again is 2. So power 1 you do not have to put. And just put another bracket to multiply by y, which is 5 to the power 4. At the bottom I had 4 times x, x is 2, times 3 times y, y is 5 to the power 7. That's going to give me an answer of 4. And I'm going to take note of that. This gives me an answer of 4. That is important for me. Because now I'm going to come to my answer and I'm going to use the same values for x and y. My answer, however, only has an x, so I can just say x is 2 and it has to be squared, and that is equal to 4. And as long as these two values match, then you know you've done it correctly. If they, however, do not match, you can go to the previous step, apply the same logic, give x and y each their individual number you've assigned to it, and see if it matches with your original one. Not with your bottom one, with your original one. If it matches your original one, then that means the step is still correct. So that means you would have made a mistake between these two. And so you could go through all your steps, tracing backwards, till you find at which step you've made a mistake. Okay, but that is just a general thing with any expression that involves a variable. If you pick a value for it, you can test your answer. The values, if I pick a value for x and y and I use it over here and I use it in my answer, they have to be the same because that is the point of simplification. We are trying to make this expression here simpler without changing the actual calculation, without changing the value. So all of this means the same as just x squared. Same as all of this up here means the same as just b squared divided by 2. And you are more than welcome to pick a value for a and b and go and test it here as well and see if you get the same answer top and bottom. Okay. In the next ones we'll look at law 3 and 4 as well as their combinations. So we've still got a couple of lessons to go. Let's hope you are keeping up.